Say welcome once again to this one more breakfast, and I just would like to tell you this isn't like just any morning. It's not when you're coming for breakfast at us, of course, anytime. But this time also we bring together the real kind of big issues in this room. I mean, we have now as our honored guest Owen Gaffney, yeah, sorry, who is with the Stockholm Environment Institute, as you know, but also head of communications of at least the hub of Future Earth.
Yeah, well, actually, International Future Earth. Yeah, I'll talk a little bit about Future Earth here, and head of media for the Stockholm Resilience Centre.
Yeah. And you know, Future Earth is if you thought that science was just about kind of narrowing into a nuclear particle or studying some special tribe at Södermalm, or it's not only. This is bringing the top science of the understanding of Earth as a system, not only climate, but biodiversity, how this Earth really works in the natural science of that, together with the best science of how the human systems of the Earth, the social systems, the governance, or how we understand the planet and govern it as human beings. That is kind of Future Earth. So you see, it's the big thing. And in a time where we're talking about maybe that we're also entering into even a geological era of this Earth, which is, yeah. So, and we bring Owen together with Johan Falk, and talking about social systems, the global great companies is one of the most important social innovations of our time, of course, and a company that's also done part of this other revolution of information making, and the information webs that connects human beings and our knowledge and information, but also in an increasable way connecting the social society with the Earth system, natural system, and having all this information, which hopefully then give humankind the ability to handle this crisis we have created ourselves. So in this room this morning, as you understand, we're bringing kind of the great issues of our time together, and I should not be any longer in my introduction, and you can, well, you already did, but give a more kind of practical introduction of yourselves and into today's subject. And I know these two gentlemen, they will kind of bring some questions back to you at the later part of this hour too. There are a few problems they haven't solved yet, so it's just that we invite you to contribute. Okay, gentlemen, the floor is yours. Welcome. And of course, then Intel being one of those companies in the forefront, they're of course also a member of Sustainable Innovation in Sweden, of course, with the Swedish one, which is obvious, but just in case you go to
we do a lot of very good things together. Yeah. Maybe we mention that as well, yeah.
Yeah, and we will.
Yeah, we have this idea here, which I don't think is necessarily a new idea, I would say. But I think the basic thinking is, okay, we've gone through a number of industrial revolutions, right? Whereas the third is the digital revolution. And is there an opportunity we can actually apply the thinking principles or key success factors from what we call the Moore's Law, which we will talk about, to really drive the sustainability objectives, you know, to go faster, to take a steep curve, because we are in a very critical moment, right? And that's basically how we started that discussion. And would you like to fill in?
Yeah, sure. We had this discussion last week at Intel's office about the state of the planet. I think that introduction was absolutely fantastic, actually, and describing what Future Earth does, and the research community globally, what the kind of things we're working on. I'm going to speak for about 15 minutes about the sort of state of the planet. But over the last 6 months or so, there's been some really big developments globally with climate agreements, with the Sustainable Development Goals, and this real new shift in worldview as we enter this fourth industrial revolution, which the tech community is talking about a lot, and was the framing for this year's World Economic Forum in Davos. We're entering a fourth industrial revolution, and then how do we sort of power this industrial revolution to really drive for a resilient, stable planet? And so over the last 6 months, I guess, Johan has been talking to me a lot about, we've been discussing this idea of Moore's Law that has had such a huge influence in the tech sector since the 1960s, and it's really driven huge innovations. It's actually changed the way this world works and the societies work. And it's not a natural law, it's a law that everybody has decided they're going to follow. And this has caused huge amounts of change. So our thinking is, well, how do we apply this law to sustainability in some way? So tell us a little bit about Moore's Law. What is Moore's Law? Because this is coming straight out of Gordon Moore, head of director of research at Intel in the 60s.
That's right. So we have, I'll actually show you a slide as a bit further down. As you can see, we improvise here a little bit, right? So it's really interesting because this year, well, last year, 2015, we also realized we have this 50 years anniversary of Moore's Law. And this year is also important from another perspective, and I think we'll come back to that. In human history, that's really key turning point, right? Moore's Law is basically about that we are doubling number of transistors every 18 to 24 months. And it's started as an observation. It's not, as you said, a natural law, it's an observation, practically, right? And that means that we continuously shrink computing down to what we call nanometers, okay? We're at 40 nanometers. A lot of people said that this law should be dead a long time ago, but it's continuing, and we look ahead another 5 to 10 years, right? And this is basically the reason why we have been able to drive the digital revolution. Just think about it. If we would, instead of every second year, if we would have taken 3 years to reach that doubling, we wouldn't have had Google or Facebook, and Apple would just have closed down their Newton development. You see the impact, actually, of that particular law. And you can actually, if you would apply it on another industry, if you could actually apply it on a flight from Stockholm to New York, you would be able to bring in more than, I think it's far more now, because this is a little old slide, more than 120 million passengers in the plane, right, in 8 minutes, right? And if we look at other industries, should there be an opportunity here? Let's see, to actually utilize. So if you look at the percent where we have driving computer systems between 78 and 2008, it's 2 million %, right? Versus other industries like lighting, 300%, automotive, 40% in terms of energy efficiency, agriculture, 132%. So there should be absolutely an opportunity to utilize this force. In order to do that, we need to understand a bit what are the key success factors behind Moore's Law, and are there some examples. So we'll come back to that in the next stage. What I think is the absolute most important thing for me and for everyone, and also changed my mind shift, was actually to really understand the state of the planet. Because that is actually what would motivate you every morning when you understand that. Once you understand it, you can't shift your mind. So we'll come back to that at the end as well. So therefore I think we should start there, because that is the most important thing.
Okay, so
that we will understand that.
And yeah, we'll get back to this again on the Moore's Law thing. That as you said, when you get on the Moore's Law curve. You know, it's not a natural law, but it became a self-fulfilling prophecy. It became, because everybody got on it, we just kept moving on to it. And this is like a really, really important concept, I think. So I'm going to speak for a few minutes about this. About the state of the planet.
As Owen said, the self-fulfilling prophecy is what Moore's law became, because everyone anticipated that we will follow this path on the market.
Okay. So let's start with the state of the planet. This is last month's temperature records from NASA globally, and this made front page headlines worldwide. So February last month was the hottest February ever recorded, you know, in the history of records going back to about 1880. And January was the hottest January on record since 1880. And in fact, the Met Office in the UK, at the end of last year, they said 2016 is going to be the hottest year on record ever. And you know, it's very, very rare that meteorological agencies make predictions for the following year. But they were able to make this prediction very, very clearly, because the previous year was the hottest year on record ever. And we are in the midst of an El Nino at the moment. El Nino, in fact, you can see it on here. An El Nino is when the Pacific Ocean starts heating up rapidly, and it does this every 7 or 8 years. And it changes weather patterns around the world. A lot of heat stored in the ocean comes into the atmosphere, and the world gets a bit warmer. And it does this. It goes, and you get strong El Ninos and weak El Ninos. The strongest El Nino before this was back in 1998, and then we knew this was going to be as strong as this. But we also knew that this El Nino is happening in a different world from the last El Nino, a very, very different world. We have huge amounts more greenhouse gases in the atmosphere, even since 1998. And greenhouse gases, of course, warming. And so we know that if we have a natural event like this on top of warming, we're going to get a much warmer planet. And we're seeing this. And in fact, the figures out show that 2015 was about 1.1 degrees or so warmer than pre-industrial. And we agreed in Paris this year at the huge landmark agreement on climate change that we'll try to limit global warming to 2 degrees and really try to push it for 1.5 degrees. Well, we're already at 1.1 degrees just last year, so we're very, very close to what is considered dangerous. So this is really, really big news. Things are changing very, very rapidly on the planet, and we're very rapidly moving into a new state. But on the good news, just out yesterday, the International Energy Agency produced a report on greenhouse gas emissions globally, and for the second year running, they're predicting that the greenhouse gas emissions that aren't increasing. We're still putting huge amounts of greenhouse gases into the atmosphere, but the rate is now flatlining. So so it's just over 30 gigatons a year of carbon dioxide went in the year before last, and about just over 30 gigatons about this year, or 2015. And this is remarkable as well. This is the first time this has happened when we haven't had an economic downturn. When there's been global growth, we're seeing so we're seeing a decoupling potentially between carbon emissions and the energy. So this is particularly good news. But will it be sustainable? So is this just a blip and then we'll continue on this upward trajectory, or can we start sort of bending the curve and start driving emissions down? So these are the two key things on the state of the planet right now and our impact on it. And Sweden It's a Swedish flag. I think we just and Sweden's announced last year that, as everyone in this room will know, that it wants to be fossil fuel free as early as possible by 2040 or earlier if possible. So it's making huge inroads, much bigger commitments than many other countries. So there is some good news, but there's also a lot of worry. So the state of the planet. So this is planet Earth. If you removed all the water on Earth and put it in a ball, including the oceans, the rivers, the lakes, etc., this would be your volume here. And the fresh water is this tiny little dot here. And if you took all the air and put it as a sphere next to Earth, this is the atmosphere, 1 atmosphere. So we don't have at sea level. So we don't have a huge amount of space to play with. Now I'm going to give you a little bit of a bit of a geological history. So we're going to go right the way back 4.5 billion years to the start of the planet. And we go through these various geological periods, the Cretaceous, Jurassic, Devonian, Silurian, etc. We had life starting around here, the biosphere forms, a great oxygenation event, and we've had 5 mass extinctions. The last mass extinction was killed the dinosaurs, and it was at this Cretaceous Paleocene boundary here. 65 million years ago. And then we get to the Holocene, the end of the last ice age, which was about 11,700 years ago. And this was a remarkable period because a remarkable stable period. And I'll just show you. Here's a picture of some of the glaciers in Norway carved out through these glacial cycles that we've had, and someone's sitting on a cliff there. So we came out of the Holocene about 11,700 years ago, and for about 10,000 years the temperatures have been remarkably stable. And so humanity arrived on Earth about 200,000 years ago. This is ice sheet data, there's ice core data on global temperatures. So this is 0, this is minus 20. So we're going to watch how how Earth travelled through the last 100,000 years. And we can see that temperatures went up and down over this period, by about 20 degrees or so, until we reach this period at the end of the Ice Age, the Holocene, when we see this remarkable stability. In fact, Earth's temperatures in that period didn't go up or down more than 1 degree. And as soon as this happened, agriculture emerged. Our civilizations started emerging. Cities started emerging. So this climate stability was extremely important for everything we have around us. So this is the Holocene. So now we're going to talk about
So on the Anthropocene, which I think is incredibly important for everyone to understand, how many know what the Anthropocene is? Okay, quite many.
So I'll take people through the last 200 years on Earth. So we had the Industrial Revolution started in about 1750. We'll have an x-axis for time here. With two or three incredible inventions that started off in Great Britain and then started spreading throughout Europe and North America, Japan, and elsewhere. And the world started industrializing rapidly. We started getting more roads, more trains, people started swarming to cities. And then we had the second industrial revolution in the 1800s, early 1900s with electrification and transport and fertilizers were able to feed billions more people. Medical discoveries saved millions of lives. And then hit 1950. This is when things really took off with marketing, advertising, globalization, and consumption on an unprecedented scale. By the 1960s, we started hitting this third industrial revolution related to computers. But we also started noticing impacts on the Earth system with this huge change that we were making. We started, the oceans were becoming more acidic, we were more carbon dioxide in the atmosphere. Our energy use was growing exponentially. We use an area the size of South America to grow our crops now, and we use an area the size of Africa for our livestock. And we started losing biodiversity at mass extinction rates. We're now actually on the verge of a 6th mass extinction of life on Earth. We made a hole in the ozone layer, and we need the ozone layer to protect life on Earth. So all these huge changes to the Earth system, this complex system of ice sheets and atmosphere, soils, oceans, that combine to create a habitable place for us on Earth, started changing, and in fact we are the main driver of change on that. So in the year 2000, the Nobel Prize-winning chemist Paul Crutzen suggested that we weren't actually in the Holocene any longer. That the Holocene we'd been in, this stable period in Earth's history for 11,700 years, was actually at an end, that humans were the main driver of change, and we'd entered a new geological epoch, which he called the Anthropocene, which is quite a profound shift in thinking and a shift in responsibility for us as a species on Earth. So we created this film. This film opened the Rio Plus 20 summit, and it's introduced by Ban Ki-moon back in 2012, the third Earth Summit. The first Earth Summit was, as you know, in Stockholm in '72. So we moved from being a small world on a large planet in space of a single human lifetime to being a big world on a small planet. So this concept of the Anthropocene has really started taking off. It's broken out of the Earth system science community and geologists, and it's now being discussed in books, in The Economist, in other academic disciplines. So, world population in 2100. It's a bit early for a quiz, but so where are we as a planet? Where are we going now? So, who thinks that by 2100 we'll have 9 to 10 billion on Earth? 10 to 12? 10 to 12? 20 to 25? 50 to 60? Sorry? That won't work. That will not work, yes. That's true. Yeah, it's about 10 to 12, maybe 9 to 10, but on some estimates, I think the latest UN is it's 9 billion by 2050, 10 to 12 by 2100. So in fact, this is one of the good news stories, is that actually, we're not on an exponential trajectory for population. This is being addressed. It's growing rapidly, but it's becoming under control. And the ozone hole, here's Antarctica. This is the other good news story, is that we discovered the hole in the early 80s. We had international policy on it by the late 80s, and now, just in the last 2 years, NASA has said that the hole seems to be stabilizing and could recover by 2100. So there are some positives here. So here's like an ECG. It's a doctor's. Does Earth have a pulse? And with these sort of ECG monitors, you don't need to know what all the lines mean. All you're looking for is like a steady signal, and you want to keep that steady signal for the patient's vital signs. So does Earth have a pulse? So again, we're going back. This is an 800,000 year ice core record. I think this is, up there with Einstein or Higgs boson as some of the most important discoveries in science in the last 100 years. These ice core records. So these ice core records show us 800,000 years of ice age cycles. And we look at some methane, temperature levels, CO2 levels, and here's 800,000 years ago. Here's today. Humans arrived here 200,000 years ago. And so we're looking at today. So what happens now? So this is where we are right now for methane, which is more powerful greenhouse gas than CO2, and CO2 in green. So this is beyond natural boundaries. We hit 400 parts per million. The natural boundary is 280 parts per million during these cycles. And methane up there, so much bigger. So, does Earth have a pulse? Yes, and if you're a doctor, you'd probably want to know, what happened next to the patient here. And this is the huge area of research going on, Stockholm Resilience Centre and Future Earth now. What is going to happen next on Earth, given this is the scale of change we're making to it? So, one of the key things we're looking at is tipping points in the Earth system. So, what is a tipping point? Well, this donkey and cart have hit a tipping point. They didn't think this would happen to the donkey, just adding a little bit more. I like the phrase, the straw that broke the camel's back, which is, reads across in all languages. There's some sort of similar phrase. You just keep adding a little bit of straw, and then suddenly the system doesn't do what you expect. It changes. and the camel system or the donkey system. And now we're looking at the Arctic sea ice system, and we're seeing very, very rapid changes there. We're seeing it reduce very, very rapidly. And we need this as Svalbard. And it's important that this, the sea ice is reducing because white reflects heat back to space, huge amounts of heat back to space. It's the albedo effect. So this is Svalbard. This is huge areas of white on planet Earth reflecting heat back to space. As we melt more of the sea ice, then you get dark water that absorbs heat. So you get a cycle. You know, if suddenly you're reflecting heat back to space and now you're absorbing it, then the absorbing will cause more melting and you'll expose more dark surface and that will absorb more. So you get into these feedback loops, these tipping points that we want to avoid. And in fact, this is two research papers in 2014 looked at what's happening to Antarctica and suggested that started melting. Parts of it, the West Antarctic ice sheet, are melting in a way that's gone past the tipping point, that it'll just keep on melting now, there's nothing stopping it. And this led to big headlines worldwide. The eventual collapse of West Antarctic glaciers appears unstoppable now. And so these are big shifts that we're seeing on Earth. And you can look at other sort of global tipping points related to the monsoon systems, what's going to happen to El Nino in the future, what's going to happen to the Amazon rainforest. You know, will these reach tipping points and start changing into savanna areas, or changing irrecoverably and not operating as a whole Earth system in the way they used to? The coral reefs, for example, we might start you know, 1 to 2 degrees rise. We're going to start seeing less coral reefs, and there's combined pressures on coral reefs. There's ocean acidification, there's eutrophication from fertilizer use, there's overfishing, there's temperature. So these marine ecosystems have got these big pressures on them. And then and the global forests. You know, this is the Amazon rainforest in 3 to 4 degrees above pre-industrial. Will it start changing irrecoverably into a different system and stop absorbing a lot of the carbon that we're already putting into the atmosphere, which is a big worry. So in other tipping points, you can see tipping points in social systems. There's research coming out about the stability in the Middle East being affected by droughts, unprecedented droughts that have been linked to climate change, to man-made climate change, actually driving people to cities and creating instability, social instabilities, and then you end up with tipping points as political systems collapse and you get migrations into Europe. And of course these are very, very complex. There's many, many different factors also linked to the Arab Spring, but the Arab Spring itself was linked to food security in Russia and Australia, not exporting grains to the Middle East, and food prices rising, and then those rises in prices contributing to destabilizing the kinds of background rate. Carbon dioxide, highest rate in 65 million years possibly, 100 times faster than the last deglaciation. Global average temperatures are rising 170 times faster than the Holocene baseline. Nitrogen, possibly the most rapid rise in 2.5 billion years. Earth is 4.5 billion years old. Ocean acidification, highest rate in possibly 300 million years. Sea level rise, paper last week or so, saying at least as fast in 2,000 years. So we're seeing major changes. So if we have the Anthropocene plus tipping points plus the Holocene, what does that leave us with? So then in 2009, some researchers at the Stockholm Resilience Centre led an international group to actually look at the stability of the Earth system and what keeps us within this Holocene stability. What are the main conditions? What are the pressure points that we need to look out for? And they identified 9 planetary boundaries we need to stay within. And then they updated this paper last year. And so for those 9 boundaries, climate change, chemicals, biodiversity, land use change, freshwater use, our use of fertilizers, ocean acidification, pollution, ozone depletion. They identified that we've crossed 4 of those boundaries, that we're running risks of hitting these tipping points in the Earth system. And the 4 boundaries relate to climate change, to biodiversity, to deforestation, and to our use of fertilizers. And we need to really, so they would be the key priorities that we need to start addressing. And we have, last year the world agreed the Sustainable Development Goals. These goals 13, 14, 15, very much based on sort of boundaries thinking. And these are 17 goals for people and planet. And this is a shift in worldview. I mean, in the document is extremely good read for a UN document, you know, but it talks about exactly what I'm talking about here. It talks about the risks to Earth's biosphere and the living systems if we continue as we are. And the main goals in here are to, you know, end poverty and create a sustainable planet. So we are seeing this shift in worldview. Now, Future Earth has set up. We've got 5 global hubs to coordinate research on global sustainability and find solutions. The Resilience Centre is doing a huge amount of work in this space. We're very closely linked to that. So we have 20 major international projects, you know, networks of 50,000 people, and growing all the time. We'll be announcing 3 offices in Africa in the next few weeks, for example. So we are here. This is this is the Global Carbon Project's budget. And I've mentioned this already, that we've actually then reached this peak here last year. Global emissions only increased 0.6%. The rate of global emissions increased 6.6%, and they're due to decrease a little bit by the end of 2015. So we're a long way from zero emissions, but things are changing, and this is largely down to China's move from coal. They've made huge investments to get away from coal, and they're reducing their reliance on coal very rapidly. And now we're seeing that investments in renewables globally are beginning to kick in, and this is starting to dent global emissions. So we're reaching a tipping point here for sure. So here we have, probably most people aren't quite aware of how much change we're seeing. In the last 10 years, about 40 countries or so have been on an average downward trajectory of their greenhouse gas emissions. So there's a huge amount of change already built into the system. And we have COP21, which I mentioned. But COP21 talked about this 2 degrees, and maybe I'll just finish with the risk of 2 degrees. That the research out last year showing 2 degrees past sea level rise for 2 degrees above pre-industrial, sea levels would stabilise 6 to 9 metres. That's what happened in the last installation 125,000 years ago. But 6 to 13 metres when 400,000 years ago, when we were at 286 parts per million for carbon dioxide. The last time we were at 400 parts per million carbon dioxide, which is what we're at now. Sea levels stabilised at least 6 metres. They can't put an upper bound on it because of geology. Earth goes up and down, and it's very difficult to measure going back 3 million years to put exactly a state on it. But we're looking at least 6 metres, and given the other trends, substantially more for that kind of carbon dioxide level. So here we are. We've got the 4th Industrial Revolution. Mechanical, electrical, digital, technological. This 4th Industrial Revolution really needs to be focused on driving stability of the Earth system. Without doubt, everything to do with that revolution must be about decarbonising, about improving biodiversity, improving our ecosystems, improving the stability of the Earth system, because we don't have much time to play with, and we've got a huge, huge opportunity to make that happen. So this is what we're going to start talking. We'll have a discussion now on this model for global sustainability. Instead of having an incremental, improvements, instead of like going for 2 to 3% every year, we want sort of radical improvements in decarbonisation, in Earth system resilience, in biodiversity reductions.
Yes, and I mean, the steep curve, I mean, even if a lot of people are aware, or at least some are aware of the situation we are in, the curve is not really steep enough today. We're still in a business as usual society, right? So every decision we take every day, a lot of diesel cars are sold every day, and people are taking the same decisions as yesterday. So I think that is really key issue, and then we need a lot of people, companies, organizations, people, governments, and primarily people to, I think, understand this picture and really deeply understand and have the knowledge about the Anthropocene and where we are and how people can contribute to change the course. because I think it's all these actions that will make the difference. So let's talk a bit about the sort of key success factors behind Moore's law, and can we apply some of that thinking? Okay. So as you talked about, Owen, I mean, it's really now about decoupling resource consumption. But basically, growth in human well-being from environmental impact, all focus so far has been, or most focus on economic growth, and without actually taking into consideration the environmental impact. Whereas we have to focus on human well-being and pushing down the environmental impact as fast as ever possible. To find a steep curve, it won't be sufficient to take 2% per year or so. It has to go much faster, right? And I still think with digitalization, Internet of Things, etc., this goes also hand in hand with disruption and actually an opportunity to drive the business values in combination with that. And we have tons of examples about that. There is no contradiction between driving down the environmental impact and creating new business opportunities. That's extremely important. So if we look at some of these are basically, if you look at Moore's law, what is really important, because it became a self-fulfilling prophecy. Everyone worked against it and invested and ensured that it happened over 50 years, right? What was the reasons for that? The first thing is to have very sharp goals. So we follow these very sharp goals even without knowing that they could be implemented. You didn't know 10 years ago, you didn't have a clue which technology to use 10 years ahead, right? I think that is really important. And I guess now with COP21, that are really sharp goals, right?
Yeah, there's sharp goals in that the overarching goal is, greenhouse gas emissions neutrality by sometime after 2050. There's a strong signal there that the world has to decarbonize sometime after 2050. The reality is, though, that we have a specific carbon budget. We have like 1 trillion tons of carbon dioxide we can emit, and we can't go beyond that. And we have the very big reality that global emissions have to peak by 2020 and have to fall to pretty much zero between 2040 and 2060 for us to stay on a trajectory that might get us to 1.5 or might eventually stabilize temperatures at 1.5. And there's still uncertainties there. So that sort of language isn't in the COP21 document, but overarching. It's a great achievement getting there. It's better than having nothing. So very, very positive. But people need those sort of harder targets to really understand where they need to go, I think.
I think really to follow an exponential curve was really extremely powerful, right, in Moore's law. So basically, if you look at Moore's law, we're talking about something like 30% per year. But if you look at emissions, I guess, per sector, something like, we need to get on a steep curve, like 5 to 10%, right? But I think the 5 to 10% thinking has to be implemented on country level, city level, might be Kista, our community, in the sector, in our company, in every company, right? In the public sector. And also you can apply it on the personal level, right? And you need to understand what is your footprint, how can you push it down. I also show that this is, basically achievable. There are a lot of examples, it can be done, but it's about the mind shift, I think. What made this possible in terms of, in Moore's law, is of course continuous innovation, and it's a mix of incremental improvement where you basically start to measure things and you start to carve out, improve combination, but then over time you also have to have some radical innovation in order to follow an exponential curve. That's quite clear, so there has to be a combination. it wouldn't have worked otherwise, right? And just one example of a project in Sweden is called the Zero Project, which I think is quite interesting. It's implemented by Marcus Robert, basically on company traveling, right? So they apply a little bit of these principles. Basically look at what are the menus that you can work on, that's on a quite detailed level, right? And how you can start to push down your CO2 footprint in terms of traveling. That's a working method, right? And it's also really interesting that cost saving will go hand in hand by pushing down the CO2 emissions in basically every case, I would say.
And this is driven by data on people's personal emissions.
Exactly, because we come to the next step. That's basically what you have to do. If you don't measure...
15 minutes left.
15 minutes left, right? We have to measure, and this is a key success factor. We have to start to measure to know precisely where we are. What's not get measured won't get done. I think someone in Intel said as well. And that's quite true. And also report out regularly. No, not every third year or so. We need to have a pace of a quarter ecology or something like that. Or at least every year, so we know we are on track. We should work transparently, we should show this data. Very important. There is a lot of power of visualizing, there is a lot of power of benchmarking. So we can apply the principles from Moore's law and economy, also in driving down our footprint. So these are just a couple of examples. Of course we can start to show the footprint in Kista, all the buildings, construction sites, how they push down their footprint. The traffic system, if we make that visual and say, well, we have to push down both the particles as well as emissions in Kista by 7% per year. How can we do that? Well, we can shift the policy for leasing cars. It's a low-hanging fruit, right? As an example. Benchmarking competition. This is an interesting example that when you start to publish this type of information, that they down there, you can compare where are you on the map compared to other companies and other actors, right? I already talked, I think sustainability and business value goes very much hand in hand. This Zero project they did, which is of course just one small project, they show that of 13, most of these companies apply this process. They push down their footprint and they save a lot of money at the same time, right? We can talk a lot more about that, but now I'm coming to, I think the most important one, where we like to actually talk a little bit and discuss about that. I think the key point, it doesn't really matter which technology we have unless we do this mind shift, where we need a lot of change agents, we need planet stewardship like Johan Rockström is talking about. How can we actually achieve that? I think that is the most important question.
Yeah, certainly from so in complex systems, in people who working on network theory and how big networks operate, rather than hierarchies, this mind shift is absolutely critically important for bringing about change. If you want to change a big system like global civilization, then the big thing you need to do is change the world view of that system, change the goals of that system, change the rules of the system, change the information flows of the system. So there's four things that will help sort of drive behavioural change in all the institutes and individuals in that system. And this is the big opportunity, I think, with the fourth industrial revolution to actually accelerate that shift in worldview. And we're seeing it. We're seeing the shift in worldview is the Anthropocene and planetary stewardship and planetary boundaries and these ideas which are coming out of the scientific community and into the consciousness of the broader society. Very, very rapidly we're seeing, and now we're seeing that translate into goals, the new sustainable development goals and rules, the COP21 agreement, and even this Moore's law for sustainability as a rule that we need to get on, a positive rule that we need to get on. And the information flows, which I think the ICT sector, Intel, Ericsson, etc., some of the leaders in Sweden can play a huge role in improving the information flows so that people are getting the kind of information on the state of the planet and on their own behaviour and how these two things are interlinked on a very, very regular time. You're talking about, instead of years and years, annually, quarterly, monthly, even real time. The more real time the data, the faster you can see the feedback for behavioural change, I think.